Today, we are going to see about the construction and working of the nuclear power plant. So if you see the construction of the nuclear power plant, so these are the principal parts of the nuclear reactor. The first one is core. So here in the core only, the nuclear fission process takes place. This is the core part in which the nuclear process is being takes place, and this core is being kept in that reactor, that is dome-shaped reactor with some protective walls. Next, moderator. Moderator. The main use of the moderator is to reduce the speed of the fast-moving neutrons. Most of the moderator are graphite. It is made up of graphite or water or heavy water. So there is a difference between normal water and heavy water, soft water and heavy water. So those who are staying near to the dams, those who are using, I think even in Hyderabad also, we are using little bit of heavy water. Heavy water means, so if you are heating the water, in a vessel, that vessel will have some scale formulation. Some scale formulation will be in the surrounding of the vessel. So that is also a kind of heavy water, and it will react to the your soaps very fast. Then it is having like heavy water or hot water. Then in your if you go take your pipes, what you are using in your homes, that pipes also will have some scale contamination will be there in and around surroundings. Some scale contamination will be there. So that also one kind of heavy water. So I'll show you. Yeah. So hard water versus soft water. So which one is healthier? So if you see in the term hard water and soft water, so which determines the hardness or softness of the water, whether one type of water is healthier or safer to drink than another. Okay. Although the water is typically crystal clear, normal water is crystal, all the water is crystal clear. It contains minerals and chemicals. This the concentration of certain minerals is what creates the hardness of water. So concentration of certain minerals in that particular water will creates the hardness of the water. If you see the what is the difference between hard water and soft water? So water softening system works by reducing the concentration of minerals from the water. Instead of having higher levels of calcium and magnesium, soft waters tends to have higher concentration of sodium or salt. Generally, hard water consists of your calcium and magnesium, but the soft water consists of higher concentration of sodium or salt. So generally what we are having is what the pure water is having some minerals that also consist of your magnesium, then calcium, little bit of calcium and magnesium. So in your RO water also that will be magnesium, that mineral, some minerals will be stored in that particular water. So that water only we are taking. If you drink pure water, that is without any minerals, directly H2O, without any minerals concentration, directly if you take pure water, that will cause some damage to your stomach, intestine. So that is why the water with some minerals we are taking, like mineral water. So the thing is that if you are going to nearby shops, you are buying the mineral water. That's so that consists of certain minerals, that is magnesium, calcium, like so soft water tends to have higher concentration of sodium or sulfur. So generally, you will be finding soft water near to the sea, like a sodium content will be there, or like a borewell water will have some sodium or salt. Okay, so like signs of hot water includes feeling a film on your hands after washing them. Okay, after washing your hands, you'll be feeling some layer that is on your like hands, and also some spots will come. Okay, if you are washing that like hard water with your vehicles, car, like glasses and all, it will appear some spots and the silverware coming out from the dishwasher. So in after washing the dishes also, you'll get some like a silverware. So these are the deposit. These are usually deposits of calcium carbonate. Here in your vessels also you can find out this spots. Next one is mineral stains. So mineral stains, these shows up on the clothes when you come out from the washing machine. Like you'll be finding some small white particles, like mineral stains in your clothes also. This clothes can wear out faster because of the hardness of the hot water, and also less water pressure in your home. So if you are having like hot water, your water pressure will be somewhat very low. So that's why in our Hyderabad region also, we find like some, like most of the water what we are using is hot water only. So the water pressure is somewhat very low. So mineral deposits can form in the pipes, essentially shrinking the interior diameter of the pipes and reducing the water flow. So normally the water flow in your taps also will be reducing like anything. Next, the signs of soft water. So signs of soft water is a healthier lather. When washing clothes, this is can even you can wash your hands and body, etc. So clothes are cleaner with no mineral stains and less water and tear damage will be there. Next, healthy water pressure in your home. If you're finding healthy water pressure in your home, so that water is soft water. And also a slight sodium taste in drinking water, though in many cases a different taste is imperceptible. Okay, so that also there in the hard water and soft water. So now you can understand what is hard water and soft water. Let's come to the So like moderator we are seeing, and next part is control rods. So control rods is used to limit the number of fuel atoms that can split. So these are made up of mainly boron or cadmium, but generally cadmium is generally used, which absorbs neutrons. So next is coolant. So coolant, what it will do is it will carry your like heatness to the boiler, or it will carry the heat. Okay, so this carries the intense heat generated. Water is used as a coolant. Some reactors use liquid sodium as a coolant. So what is the main disadvantage of using water as a coolant in the sense? Again, the scale formation will be there on the pipes. So generally they will go for liquid sodium as a coolant. Next, the fuel used for the nuclear fission, already we discussed, that is uranium-235 isotope. Next, radiation shield. So to protect the people working from the radiation and radiation fragments. So generally, if you see those who are working in nuclear power station, so they will be wearing this thermal shielding coats and all, radiation shield coats and all. So if anything happens, that is radiation is coming out from the particular thing, it will easily, that port will easily resist. Even they will cover all the, even face, everything they will cover. Even they will wear some like glasses to protect their eyes also. So everything will be covered. So similarly, radiation shield also will be there in that thermal shielding. I said no, that a dome-shaped structure, in that also radiation shield, like 1, 2, 3, like that's 10 to 10 stage will be there. So if one radiation shield is getting failure means, so it will be like next radiation shield will protect from the radiation. Like that, the structure they will form. Here, if you see like uncontrolled nuclear reaction, so once it is being bombarded, once or plutonium-239 is being bombarded, like the chain reaction will be like anything. It will, you can't able to slow down that chain reaction. So like the rate of fission increases rapidly, and also a huge amount of energy is being released very quickly. So that is called nuclear bomb. So what they detonated on like Hiroshima and Nagasaki in Japan. Okay, so that is the nuclear bomb. So that is very dangerous. Some chain reaction will be forming like anything. Yeah. So here, if you see the structure of a like one picture of a nuclear power plant, In this, generally the rate of fission is controlled by artificial means. That moderator, control rods for like reducing the rate of fission. Yeah, here you can see the types of nuclear power plants. The first and boiling water reactor, and the third one is fast breeder reactor. So here, if you see the like boiling water reactor, the boiling water reactor. So first I will explain the like what is meant by reactor. Then we'll come to this slide. Yeah. So this is the schematic arrangement of a nuclear power station. So it consists of, already I said, no, nuclear reactor, heat exchanger, steam turbine, alternator, and all. So if you see, like this is the nuclear reactor, and this is the heat exchanger. Okay, heat exchanger. In this only the fuel, like uranium-235 fuel rods is being placed in this nuclear reactor, and here hot metal. Instead of using water, they are using hot metal like sodium metal as a like a heat exchanger. Sorry, it will carry the heat to this heat exchanger, that is acting as a like coolant. It will take the heat from this, and it will pass this heat to this part. Okay, so this is the hot metal we are using. Next, after this heat exchanger will be there. In this heat exchanger, this heat is being okay. Here, water is being passed from the feed water pump. Water is being passed. So after the water is being heated up like anything, because like as I said, due to the chain reaction, more amount of heat is being generated. That heat is utilized for boiling the water over here. So from this boiling, after boiling the water, we'll get superheated steam. So that is controlled by a bar. So that is heating a turbine. That is turbine is being coupled with the alternator. Then isolate like transformer that is being given to the bus. This already we have seen. That is exciter also connected to the alternator. So this part we have already seen. So I no need to explain that much. This already you know. So like exhaust steam again is coming to the condenser. Condenser condenses the steam, and also some water molecules will be there. That water molecules again is being taken to the river directly, and again the same water is being given to the cooling tower. From the cooling tower, again the water is being cooled up, and again it is being injected to the feed water condenser, again to the feed water pump, again to this heat exchanger. So this reaction will continues. So again, what we are doing is here after the heat process, this cold metal again passes to the pump. So some filter will be there that filters, and again it is being given to the nuclear reactor. So this chain, this process will repeats. Hot metal is passed to sodium metal is passed to heat exchanger. So again again this the cold metal after the heat will be exhausted. No, after that cold metal will be there. Again it is being pumped and filtered, and it is given back to the nuclear reactor. So this process will continues. This process will continues. This is the schematic arrangement of nuclear power plant. Coming to the nuclear reactor. So this is the in this picture you are seeing the nuclear reactor. So nuclear reactor. So this part separately we are seeing this part alone. That is nuclear reactor. Coming to the nuclear reactor. So this is the the pressure valve. The pressure valve. So this is the whole nuclear reactor. This is the pressure valve. So inside that, this is the fuel rods. The black color you are seeing, no? This is the fuel rods. That is uranium-235 fuel rods. So once they will be giving some 1 kg or okay, up to 5 kgs like that. So once that uranium-235 is being bombarded, so it, due to the chain reaction, it will last up to 6 months, up to 1 year. But the fuel cost, that fuel rods is costly. Fuel rods. So we are getting that fuel rods either from Russia, USSR, or otherwise from US, United States. India, we are getting this fuel rods, and almost all the technology they only establishing for us. We are just generating the power. That's it. So this fuel rods is there. Next, this moderator is there. So moderator is used to reduce the neutrons that is being produced from the nuclear fission reaction. So that is the moderator is of graphites. It is made up of graphite. Okay, so this is the control rod. So control rod is cadmium control rod or barium. So generally cadmium is being used. So cadmium control rod is used to reduce the nuclear fission reaction, because more amount of fission reaction, that is more amount of energy will be produced. So that much more amount of energy will be produced, means that much boiler you need to install. Okay, that much water you have to get heated up. It will be generated around more amount of heat is being generated. So if you go for very big boiler, then the thermal efficiency will be dropping. So that will be reducing the overall efficiency of the nuclear power plant. So generally they will be going for 1000 megawatt, 1500 megawatt. They will not go more than that. So like that, the fuel also, the fuel quantity also will be used that much only. They will use a little bit less fuel, so that the amount of heat generated also will be lower. So this is the control rod. So here, like after bombarding, so you will get enormous amount of heat. So that is being transferred by this coolant, that is sodium metal. Okay, generally, so here if you see, like generally sodium metal will be used as a coolant that is being given to the that is being passed into this tube. That is already I have seen we have seen some videos also regarding this. So this tubes will be there. In this tubes, this coolant will be passed. So surrounding in this thing, it is surrounded by the water. So water will get heated up. So water will get heated up like anything. So like superheated steam will be generated and it is being given to the turbine. So that process, you know. So after that, this coolant is again taken to the coolant circulating pump. Again, it is being transferred to this part. Again, whatever the reaction that is heat energy is taken from this coolant. Again, this cycle repeats. Okay, so this is the pressure bar, and this is being taken. Okay, so water is being given from the feed water pump over here. So steam is being taken. So very simple. Nuclear reactor also, nuclear power plant also very simple. So this is of pressurized water reactor, pressurized water reactor. So we are giving the pressurized water here and not directly to the reactor. So boiling, if you take like boiling water reactor, what they will do is instead of this coolant, they will generally give water itself to the reactor, that is pressure vessel. So generally they will give water to the reactor reactor itself, so that you can directly get to the superheated steam outside. But there is some disadvantages. Disadvantages are there in this pressurized water reactor. So what happens is this water will goes inside this reactor. So and there will be some formation of rust and the scale formation will be there. That will affect the fission reaction. So that is the main disadvantages of using the boiling water reactor. That is BWR, boiling water reactor. So that's why we are going for pressurized water reactor in this process. Okay. So if you see here, this is already known. A nuclear reactor. Nuclear reactor is an apparatus in which it uses the uranium-235 nuclear fuel is subjected to nuclear fission reaction. It controls the chain reaction that that starts once the fission is being done. If the chain reaction is not controlled, the result will be in explosion. Okay, if you are not controlling the any chain reaction, once you are just bombarding the nuclear fuel, that is uranium-235, then the reactor will get busted. That is, it will get a very huge blast. Explosion will be happening in that. So to avoid this explosion only, this nuclear reactor is a cylindrical stout pressure bar and houses fuel rods of uranium that we have seen, uranium moderator and control rods also. Okay, in the nuclear reactor we'll be having fuel rods, moderator, control rods. Here you are seeing no, yeah, here. So it contains control rod, moderator, and as well as fuel rods. That is uranium-235 fuel rods. Okay, here the fuel rods constitutes the fission material and release huge amount of energy when bombarded with slow-moving neutrons. The moderator consists of graphite rods which enclose the fuel rods. The moderator slows down the neutrons before they bombard the fuel rods. This moderator slows down the neutrons. Okay, so no need to study of this. So once you see the diagram itself, you can easily understand what is the moderator like. So moderator which slow down the neutrons before they bombarded the fuel rods. The control rods are made up of cadmium and are inserted into the reactor. Cadmium is strong neutron absorber. Cadmium is strong neutron absorber that and thus regulates the supply of neutrons for the fission. When the control rods are pushed in deep enough, they absorb most of the fission neutrons, and hence few are available for chain reaction, which therefore stops. Okay. However, as they brings withdrawn, okay, if you push the control rods into fully, it will absorb the fission neutrons and therefore the chain reaction will be reduced. You see here, if you insert this control rod here, if you insert the control rod here, automatically this will reduce the chain reaction, so that power generation also will be reduced, and also fission reaction also will be reduced. So meanwhile, if fission reaction will be reducing, means meanwhile the power generation also will be reduced. Same like that, if you taken away, so fission reaction will be of if you taken this control rod from this nuclear rods, that is fuel rods, so nuclear reaction will be of more, then automatically power generation also here will be more. So fission reaction will be more that time. Therefore, by pulling out the control rods, power of the nuclear reactor is increased. Whereas by pushing them in, the power generation will be reduced. In actual practice, lowering or rising of control rods is accomplished automatically according to the requirement of the load. So based on the demand, based on the requirement of the load demand, it will be automatically, that is feedback. Feedback is being given to the from the bus to this control rods. So if you want more power to be generated, yeah, if you want more power to be generated, automatically you have to you have to pull out the control rods. If you want less power to be generated, you have to insert accordingly. So how much power 1/4 or 3/4 or 1/2, like that, it can be inserted accordingly. So this coolant carries the heat to the heat generator. The heat produced in the reactor is removed by the coolant. So generally sodium metal is used. The coolant carries the heat to the heat exchanger. So here you are seeing the small dots, no? That is the coolant over here. That is the sodium metal. Okay. So next is heat exchanger. So what is the main use of heat exchanger? In the sense, the coolant gives up the heat to the heat exchanger, which is utilized in raising the steam. After giving up the heat, the coolant is again fed to the reactor. After giving up the heat, the coolant is again given to the reactor. So this chain reaction, what is the chain reaction? Nuclear fission is done by bombarding uranium nuclei with slow moving neutrons. This splits the uranium nuclei with the release of huge amount of energy and the emission of neutrons. That is called fission neutrons. These fission neutrons cause further fission. If this process continues, then in a very short time, huge amount of energy will be released, which may cause explosion. This is known as explosive chain reaction. This like nuclear bomb will work on this reaction, that is explosive chain reaction. But in the reactor, controlled chain reaction is allowed. So this controlled chain reaction, so you have to write like controlled chain reaction is allowed. This is done by systematically by removing the fission neutrons from the reactor. The greater the number of fission neutrons removed, the lesser is the intensity of the energy released. So next thing is steam turbine. Steam turbine. The steam turbine produced the steam produced in the heat exchanger is led to the steam turbine through a valve. After doing useful work in the turbine, the steam is being exhausted to the condenser. The condenser condenses the steam, which is fed to the heat exchanger through feed water pump. So next is alternator. So alternator, you know, the steam turbine drives the alternator, which converts mechanical energy into the electrical energy. The output of the alternator is delivered to the bus bars through transformers, circuit breakers, and the isolators, which is given to the, which is connected to the bus or to the grid. After stepping up, it is given connected to the grid. So next topic is next. Now we'll go to the So these are the two types of like a nuclear reactor. I said like a pressurized water reactor (PWR). That is what we have seen now. That is the coolant we are using now. That is the pressurized water reactor. So pressurized water is being given to that heat exchanger. So that is called pressurized water reactor. Same figure is shown here. Okay. So if you see here, this is the reactor core of the reactor. Next fuel rods. This lines are called fuel rods. Next is concrete shielding will be there. So around surrounding this reactor, concrete shielding will be there. Next this is the coolant. What we are doing is we are passing over here. So coolant we are passing over here. So here if you see like pressure equalizer. So pressure equalizer is to equalize the pressure that is being in that particular this tubes. And also steam generator, you know, after that it is passed to the tubes. So water is being pressurized water is given to this water, that is S type tubes, so that the heat is being exhausted to that water. So water is being heated up, and enormous amount of steam is being generated, and it is being given to the steam turbine that is coupled with the generator. So again, the cooling water is being taken, and cooling water is and again the exhaust steam is given to the condenser. Again it is being given to the river, and sometimes same water is given given to the cooling tower, and again it is coming to the feed water. Again it is being given to the steam generator, so that this process will circulate. So if you see the boiling water reactor, what we are doing is we are giving the water directly. We are giving the water directly to the reactor itself, and we are after that the water is flowing to the steam separator. There we are separating the steam, and we are giving that steam to steam turbine. So this is one type. So the main disadvantage, limitation of this boiling water reactor, I said. So due to the formation of scale formation, then rust formation will be there, and nuclear fission also will be decreasing. So that we are going for this pressurized water reactor. So if you see, like, heat is produced in the reactor due to the nuclear fission, and there is a chain reaction. Heat generated in the reactor is carried away by the coolant, that is water or heavy water. So we have shown the difference between the water and heavy water circulated through the core. The purpose of the pressure equalizer is to maintain the constant pressure inside that particular reactor. This enables the water to carry more heat from the reactor. The purpose of the coolant pump. What is the purpose of the coolant pump? In the sense, coolant pump is to pump the coolant water under the pressure into the reactor core. So next is the steam generators. The steam generator is the heat exchanger, where the heat from the coolant is transferred onto the water that circulates through the steam generator. As the water passes through the steam generator, it gets converted to the steam. Next, steam produced in the steam generator is sent to the turbine. The turbine blades rotates. So whereas it is that steam superheated steam is hitting the turbine, so that the turbine blade rotates. The turbine shaft is coupled to the generator, so that the electricity is being generated. After the steam performing the work on the turbine blades by the expansion, it comes out. It's come out from the from the turbine, and again it is being converted back to the water and being circulated by the feed water pump. Okay, and feed water pump pumps back the condensed water to the steam generator. So this is the schematic diagram of the nuclear power plant with pressurized water reactor. As I said, this is the control rods. Next, this is this small lines are the fuel rods. Okay, fuel rods. It's the same procedure. Same procedure. Here also same we are doing. Okay, so it is passed as like water or coolant is being given to the this like series of the pipe, so that the water is pressurized inside the steam generator, so that steam, high pressure steam, superheated steam is being generated, and it is being given to the turbine. So same thing. It is power is being generated. So fuel rods. Fuel rod, it consists of uranium-235. They are surrounded by a moderator that is consists of graphite or water to slow down the neutron released. That is also there. Next, control rods. So control rods controls the rate of reaction by moving in or out of the reactor. If it is moving in, the rate of reaction is reduced. If it is moving out, the rate of reaction will be increased. When all are moved in, the reactor will be shut down. Okay, if you want to shut down the nuclear reactor, then if you push all the control rods inside the like a fuel rods, means automatically the entire power plant becomes shut down. So these control rods are made up of mainly of cadmium or boron. So this absorbs the neutron. So next is this turbine. This turbine, the steam drives the turbine, which turns the generator. Electricity is being produced by the generator. Then this, if you see, like two separate water systems is there, are used to avoid the radioactive substance to reach out the turbine. So that's why we are using the another water separators also being used, and also we are not taking directly that water here. If we are going for boiling water reactor, we are inserting water directly to the hole, that is inside the reactor itself. We are giving the water directly to the reactor itself. So that will also have some, that water after coming out from the reactor, that water or that steam also will have some fission, nuclear fission will be there. Some radiation will be there. So those who are working in that particular steam turbine, near to that power plant, if they inhale, or again that that is being taken to the cooling tower, there also if some workers will inhale, and sometimes it is going out to the atmosphere, there also it will cause some radiation effect will be there. So that's why we are avoiding the water directly to the reactor, so that we are using the coolant. Instead, we are using the coolant to the reactor, so that we'll avoid all this radiations, radioactive substances. Okay, and also if you see, like the energy released in fission heats up the water around this reactor. The water in the secondary loop is boiled and converted to the steam. This is the each and every parts I'm explaining. Yes. Yeah, this is the boiling water reactor. So boiling water reactor, as I said, water is circulated to the reactor, where it converts to the water to steam, water steam mixture. The steam collected above to the steam separator. This steam is expanded in the turbine, which in turn turns the turbine shaft. The expanded steam coming out of the turbine is condensed and is pumped back as the feed water by the feed water pump into the reactor core. Also, the downcoming recirculation water Also, the downcoming recirculation water from the steam separator is fed back to the reactor core. So automatically this the same water is recirculated to the reactor core. Next, in this the steam power plant. Power plant means any power plant that use steam to produce electricity. So that is thermal. Same principle is being used in this nuclear reactor also. Same whatever the steam power plant working, the same working principle we are all using in the same nuclear reactor also. Next, advantages of nuclear power plant. Less space is required when compared to other power plant. Nuclear power plant is only source which can meet the increasing demand of electricity at reasonable cost. And also, a nuclear power plant uses much less fuel than the fossil fuel plant. 1 metric ton of uranium fuel, that is equivalent to 3 million metric tons of coal. 1 metric ton of uranium coal is equivalent to 3 million metric tons of coal. That is nothing but 12 million barrels of oil. Okay, 1 metric ton is equivalent to 12 million barrels of oil. So disadvantages of nuclear power plant is radioactive waste must be disposed carefully, otherwise it will adversely affect the health of the workers and as well as the environment. As a whole, maintenance cost of the plant is high. High skilled workers is need for maintenance of this plant. Okay. So generally, this new radioactive waste of highly radioactive, and also many of them have very long of lives, and also radioactive waste must be stored carefully or disposed very carefully. Next, low level water. These are all out of the subject. That is stored in storage facility. Radioactive will fall to safe level after 10 to 50 years. Okay, after 10 to 50 years, you have to safely. You have to watch that radioactive substance. Then yeah, it will be that will be embedded into the strong concrete walls deeply underground. It will be stored in the deep underground or for several thousand years. Then only that will become non-active. Otherwise, it will be always